Myself, Anupama, Assistant Professor in the Department of E&C. Madam, we welcome you, Madam, on behalf of our department. Let me introduce you, Madam. Dr. Jhansi Lakshmi has done UG, PG, and PhD in UBD TCE, Davangere, attended 3 international conferences, has received Best Paper Award 2. Research areas is nano coatings, published 12 articles in international journals, presently working as professor at GEC, Haveri. Today's topic of the session is revolutionizing biomedical and mechanical engineering. Thank you. Hello.
अरे
Madam, am I audible to you, madam?
You're audible, ma'am. Presentation
fine.
is also visible.
Okay. Visible now, madam? Okay, fine.
Yes,
Okay.
yes. Okay.
Good evening, everyone. Good evening, everyone. Thank you, madam. Thank you for a brief introduction about me.
Okay, we
I'm
welcome
Dr.
you.
Jhansi Lakshmi, working as a... Thank you, madam. Today, I am discussing about nanomaterials revolutionizing biomedical and mechanical engineering. In this presentation, we will see how nanomaterials are revolutionizing the mechanical engineering field and also the biomedical field. Because I am from mechanical engineering field and I have done my research using nanoparticles, I have chosen this mechanical engineering field also. And as this FDP is concerned with the biomedical one, I'm just putting a little light on the biomedical applications also, uses of nanomaterials in biomedical applications. Let us understand what is meant by a nanomaterial. Nanomaterials are the materials with at least one dimension in the nanoscale. That is, nanoscale is 1 to 100 nanometers. Nano is, as we all know, it is 10 to the power of minus 9 times of a meter. That means it is 1 billionth of a 1 meter. To give a little brief idea about the size, we can see that the very thin hair of any healthy person will be of 60 micrometers, whereas the nanomaterials will be of 5 to 50 or 1 to 100 nanometers, will be that much. The nanoparticles will be of such a small size. This small size have given them the extraordinary properties, and because of these extraordinary properties, the nanomaterials are used in almost every applications nowadays. Nanomaterials can be composed of various substances such as metals, ceramics, polymers, or even composites. See, as we were discussing about the sizes, this hair is of 60 micrometers and bacteria can be of 0.15 to 2 micrometers. Whereas this DNA is of 2 nanometers, which will be there in our body. Then this UCNP, that is upconverting nanoparticles. This is one type of nanoparticle which will absorb multiple low energy photons and emit a single high energy photon. This is one type of nanoparticle. We will be discussing about these nanoparticles little later in this presentation. And this is also the nanoparticles which we use very widely. This is, we call it as a carbon nanoparticle, and it is named as fullerene, which will be like a hollow football. This nanoparticle can be synthesized by the evaporation of graphene in vacuum. These nanoparticles, the characteristics also will study, but as of now, they will be of very lightweight in structure, lightweight and very strong in nature. And these are QDs. What are they? This is the quantum dots which are used, which is of a size of 1 to 5 nanometers. And this is golden nano particles, AUNPS. These all nanoparticles are widely used in biomedical and electronic and mechanical appliances. Hello? 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 Am I audible?
Yes, ma'am, you're audible.
Hello? Okay, okay. There was little bit disturbance, madam. So I know. Okay. So coming to the history of nanomaterials. Knowingly or unknowingly, the nanomaterials were used very way back in 4th AD and 8th AD only. This we can see in the British Museum. This cup, Lycurgus cup, which is called as Lycurgus cup. Maybe that emperor might have used this cup. That's why that name. It exhibits, this cup exhibits excuse me, the the Lycurgus cup exhibits dichroism. That means two colors will be seen. We can see two colors here with the different light radiations. Okay, this, when it is observed in 1990, the scientists test why this special property is seen in this cup. So they found that two nanoparticles, that is silver and gold nanoparticles, in the ratio of 7:3, were mixed in copper, 10% of copper, and it was dispersed in this glass matrix, and was dispersed in the glass matrix to get this dimorphism. Dichroism. Dichroism. To get this dichroism. So similar thing is also seen in the church wall, where here also some gold and silver nanoparticles were dispersed in the glass to get different colors. Here it is given which the micro nanoparticle will give which color. The size of the nanoparticle will also say change the color, because see, the same gold nanoparticles which is of 25 nanometers and which are of spherical shape will reflect red color, whereas 50 nanometer gold particles will reflect green color, and 100 nanometers size gold nanoparticles will reflect orange color. In the same way, even the silver nanoparticles will reflect different colors for different lights. So, knowingly or unknowingly, the artists at that time used these nanoparticles. But to this generation, the study was this about nanoparticles was what to say came into light after the Michael Faraday's dispersion of gold in ruby. So that, and also after the inventions of scanning electron microscopes and TEM and XRD, that is X-ray diffraction techniques, and scanning and tunneling microscopes. So the history of nanomaterials says that nanomaterials are not new in this world. It was there even in 4 AD to 7 AD also. So, as we were discussing that, the nanomaterials have unique properties. Why these unique properties of nanomaterials are observed? Because of their shape. Okay. What are those unique properties that you can see when compared to its bulk nature? That is, the copper in its bulk, as we all know, it is malleable in the nature, and also it is very soft, whereas the copper, also it is a uh, opaque substance, where in its bulk nature, in its nano size or in its nano state, the copper becomes transparent and also it becomes hard. See, exactly opposite natures are seen in nano size particles. The same way, the platinum, which is an inert material in its bulk state, it will act as a catalyst in its nano state. Whereas the aluminium, which is a stable material, which will turn into combustible material in its nano state. The gold, which is which is solid in its in its bulk phase at room temperature, will be converted into liquid at room temperature in its nano state. Okay, the same way, silicon is an insulator in its bulk state, whereas it will become, or it will behave like a conductor in its nano state. So these
Excuse me, ma'am.
unique, yes,
Ma'am, slides are not changing, ma'am.
is it, madam? Which slide you are able to see, ma'am, now?
Only the starting one, ma'am. Nanomaterials revolutionizing biomedical and mechanical engineering only.
Oh no, I have changed
The
already
main
3 to 4 slides, madam. Why it is so? Why it is happening? Okay, fine.
Uh,
Now
It
I
is not
have.
maybe you're not in presentation mode, madam. So that's the reason it seems. Maybe.
Okay,
Thank
okay, okay.
you.
Then how to change this presentation mode, madam? Can you please help me?
Ma'am, come to down, ma'am. There you have a like beside volume one symbol is there, no, ma'am. That you can click it. No? Exactly beside volume.
Beside volume,
Yeah.
here mic is there. There are more.
My volume changing button is there, no, ma'am. Like a straight line.
Hello.
But beside
Zoom bar, madam. Zoom bar.
Yeah, there is a one symbol has like a curve at the bottom of right side.
No.
You move towards left.
Uh, can
Right,
you
right
see it
now.
now, madam?
Towards right
Now,
now. That circle. Or
madam,
you can
can
write,
you?
press the F5 button, ma'am.
yes, ma'am.
You can
Now
press the
the
F5.
slides are changing.
F5.
No issue.
Now the slides are changing,
It's
no,
now
madam.
changing, ma'am.
Yes, ma'am.
Okay,
Yes,
okay,
ma'am.
okay,
Yes.
okay, fine. I'll keep it in this way only, not a presentation mode. Okay, madam.
No
Ma'am,
issue.
it is also not visible. That text is not visible to us.
Okay, fine.
So you
Now,
convert into the PPT mode, PowerPoint presentation mode.
okay, okay.
Sir,
Now,
Yes, yes.
on your
okay,
screen you can press plus, sir. You will get it.
okay. Now is it visible, sir?
No, the text color is not visible. Unique properties of nanometers I have read, but what is the below that I cannot read.
Madam, press F5, madam. Press F5. You will get big screen. Press
Ma'am,
5.
can you please zoom, ma'am? Thank you.
You can
I
upload
have
PDF
pressed
also.
F5.
It will
I
work
have
better.
pressed F5. Is it okay now?
No. Madam,
Yes, sir.
now your
Only
circle is
the heading is visible. Ma'am, you can upload PDF. It will work
yes.
fine.
Press that. Yes.
No, I have pressed
That.
it.
Yes, correct.
Now is it visible? Hello? Is everyone facing the same
Not now.
problem?
Yes, ma'am. Actually, it is not in the full mode.
The
Otherwise, you
automatic.
can stop the
Ma'am,
share and then reshare.
ma'am, it is visible, but you can do slideshow. Click on slideshow button.
Yeah.
Click on the slideshow, madam.
Yes, I have done
Yes,
that.
yes, there, yes. Click there, click there.
I have
Exact
done it,
button you
sir.
have got.
I have done it. I have done that
Ma'am, it
slideshow.
is visible from my end. Opaque
Is it
substance.
visible now?
Yes,
No,
yes,
ma'am.
ma'am.
Madam, it is visible. You just try changing the slide.
Okay.
Okay.
Now?
Did
Now
you
it's
change?
okay.
Yes.
Did you change the slide? The slide is unique
Yes.
properties of nanomaterials. Next slide.
Yes, madam. Next slide, nanotechnology in construction and cosmetics.
Oh, that is not visible. Slide is not
Okay,
changing.
fine
Madam.
then. Whenever I have to change the slide, I'll go to this one and I'll change and I'll make it a presentation. Okay. I'll press F5. Is it okay now? Now, can you see
I
nanotechnology
think
in
function
construction and
plus
cosmetics?
F5, madam. Function key plus F5.
Ma'am,
Sir, that is what I have done. See, function key F5. Now, what you are able to see on your screens, nanotechnology in construction and cosmetics.
no.
Problem
Ye-
is slides are cropping, madam.
Yes, completely not visible.
It is
Click
cropping.
slideshow. Click slideshow, madam, now.
Madam, it is in slideshow mode only now.
Ma'am, if you have PDF file, then try to upload PDF. It will work fine.
Just give me 1 second, sir. I'm extremely sorry. Now is it visible, sir? Hello?
Yeah,
Ma'am, visible, ma'am.
this is actually PowerPoint. It is partly visible, ma'am. Complete slide is not appearing on the screen.
Okay.
Yes, it is fully visible to me. I think it takes some time for some people, but it is visible completely.
Okay, fine, sir. Fine. So, unique properties of nanomaterials. As we have discussed, there are different properties of a nanomaterials. Then, why these properties are nanomaterial properties are different from the bulk material properties? It is because of the greater surface area to volume ratio. The as a particle size decreases, a greater proportion of atoms are found at the surface compared to those inside. Okay, at a particle of diameter of 10 nanometers, 20% of the entire particles are positioned on its surface. In the same wise, as on the particle size goes on decreasing, like for 5 nanometer particle, diameter particle, 40% of the material will be on the surface. That is the complete particle, entire particle material will be on the surface. Like that, because of this one, the surface atoms will have the few neighbors and they will have an unsaturated bonds. So these are responsible for the higher reactivity of the particle surface. So the nanoparticles have a much greater surface area per area to volume ratio. Because of this one, nanoparticles will show the different properties than their bulk one. This is one reason. And another one is electron confinement. As the size goes on decreasing, the movement of electron also goes on decreasing. So because of this one also the property changes. And another one is reduction in solid state defects. We all know that in a bulk material, there are chances of defects like vacancies, interstitials, and other electronic defects within the bulk material. When the size decreases, there will be less chances of defects. So, in the same way, because of this much material on the surface and interface force becomes dominant. Because of these unique properties, nanoparticles are increasingly found in a wide range of commercial products in various sectors like construction sector. So in construction sectors, nanoparticles are used in advanced insulation materials to enhance thermal efficiency and to reduce energy consumption and to create more sustainable buildings. Even the nanomaterials are have entered the cosmetics field also. The nanoparticles enhances sunscreens and moisturizers and hair care products by providing a better benefits by improving their UV protection and all. They are providing the better benefits than the conventional ones. So even in automotive industry also, the nanoparticles are used as a catalytic converters to enhance their efficiency, which will reduce the exhaust emissions and also it will improve the fuel economy. This benefits both the environment and drivers. So again, the nanoparticles incorporated in rubber tubes will increase the life of the tires and also by increasing the traction and the grip of the tires, the uh, life of the tire will be increased because of the nanoparticles. Nanoparticles are seen even in food industries also. In food industries, nanoparticles are used for nutrient delivery, to improve packaging and to extend the shelf life and ensuring fresher and more nutritious food for the consumers. In electronic sectors, semiconductor fabrications in magnetic recording media, nanoparticles are used widely. Even in textile industries also, nanoparticles are used because of their antimicrobial properties and UV protections and strain resistance. Then this biochips and even in markers also, nanoparticles are used widely. Coming to the another important one, that is the future of medicine, that is the use of nanoparticles in biomedical applications. Hello, madam, are you getting the correct slide, madam?
Yes, ma'am.
Yes, madam.
The future of
Yes,
medicine,
ma'am. Yes, ma'am.
nanoparticles
You
of drug
continue.
delivery. Okay, thank you. Okay, nanoparticles are used in drug delivery agents. What are these drug delivery agents? Especially in cancer patients, we all know that the treatment for cancer is chemotherapy. Most of the times, chemotherapy and radiotherapy are used as a treatments for cancer. In chemotherapy, cancer anti-cancer drugs were given. It is like leaving a leaf in a water stream. We don't know where actually it will end up. These cancer drugs, okay, these cancer drugs have the tendency to kill all the cells, whether they are healthy cells or carcinogenic cells. It will kill all the cells, including the immune system. It will kill the immune system. That is even white blood cells of the system will also be killed. This will improve the toxicity inside the patient, and also the patient will become very weak, and eventually leading to the death of the patient even after so many chemotherapy sittings. But because of these nanoparticles, they are providing the drug, they are acting as a drug delivery agents. That means when the drugs, cancer drugs, are inserted into the nanoparticles, and they are sent into the body through, they work as a drivers which will take us to the destination. It will go and hit the only cancer cell. It will not hit the healthy cells. So this is how the drug delivery agents work. They work as a driver who knows the destination. Drug delivery agents, many nanoparticles like silver and gold nanoparticles, and iron and platinum and titanium oxide, these are all the nanoparticles which are used as a drug delivery agents in cancer treatments. Coming to the second, this one, that is regenerative medicines. What are regenerative medicines? Nanoparticles hold immense promise in regenerative medicines, promoting tissue generation, regeneration, and repair, potentially revolutionizing the treatment of injuries and diseases. That is, growth of a new or repair and replacement of defective tissue or an organ by using stem cells with compatible biomaterials containing certain biological active components is the basic concept of the tissue engineering. Tissue engineering is a multidisciplinary concept which merges biological sciences with engineering concepts and material knowledge. Even though much has been achieved in the field of tissue engineering, still there are so many challenges in terms of the availability of potential or active cells, and the strength of the biomaterial used, the cells obtained, and cytocompatibility also this one. All these problems, are all these issues are addressed by using nanomaterials, which will, these nanomaterials will mimic the natural properties of cells and tissues. So even the nanomaterials are used in regenerative medicines also. Coming to the next application, that is bioimaging. What is bioimaging? There are different bioimaging techniques like MRI, that is magnetic resonance and imaging, computed tomography, positron emission tomography, that is PET scan. These are all the scans and ultrasounds which are used for detection and diagnosis of diseases. In these things, when we see that whenever an MRI scan is given to a patient,
Hello, madam.
Hello.
But it's audible. You can continue the session, madam. It's audible, madam.
Are you able to see my screen, sir?
Yes, madam. Yes, madam. It's visible, madam. You can continue the session, madam.
Okay, sir. Okay. So bioimaging. So I was there. Shall I explain this regenerative medicine and cancer therapy again? At what point my presentation stopped, sir? I know.
Madam,
Bioimaging, madam.
Okay. MRI scans. Okay. What are bioimaging techniques such as MRI, computed tomography, and positron emission tomography? These are all the techniques which are used for the detection and diagnosis of diseases. These nanoparticles, because of their very small size, will detect even the very small or minute carcinogenic tissues also. So, better the earlier the detection, better will be the cure. This is what everyone thinks, and it happens. So, because of these nano particles, in using nanoparticles in bioimaging, for example, gold plated nanoparticles, gold nanoparticles, which are coated with the membrane, some biomolecules are coated. This contrast agent is used for diagnosing prostate cancer. It is used in computed tomography imaging technique, and it is used for diagnosing prostate cancer. Whereas supermagnetic iron oxide, which is again, this surface is decorated by biomolecule, which is used to find out the tumors in lungs, and it is used in MRI scans. So these are all the nanoparticles which are used in biomedical applications. Coming to the drug delivery system, let us a little bit discuss what is meant by drug delivery system. It is once again targeted delivery. Nanocarriers can be designed to target specific cells or tissues, improving drug efficiency and reducing side effects. It will have even the controlled release. Nanomaterials can control the release of drugs over time, ensuring sustained therapeutic levels and minimizing dosage frequency. These nanoparticles can also improve the bioavailability. So, because of these nano materials, which will enhance the absorption and distribution of drugs in the body, increasing their therapeutic effectiveness. Classification of nanoparticles will cover almost all types of nanoparticles. That is carbon-based nanoparticles. Basically, carbon-based nanoparticles. There are two types of carbon-based nanoparticles. That is carbon nanotubes and, as we have discussed, fullerenes, which is like an empty football. The carbon nanotubes are again two types. We have two types. That is single-walled carbon nanotubes and multi-walled carbon nanotubes. Predominantly, carbon-based nanoparticles are very strong. Okay, they are used in structural reinforcements because they are stronger than the steels. Okay, carbon nanotubes, they have the very distinct property. They are conductors along its length, whereas they are insulator along its width. They have that specific property also. The carbon nanotubes. The coming to this flint structure, which is like an empty football structure, these carbon units have pentagonal and hexagonal arrangements because of their conductivity, structure, and high efficiency. Okay, coming to that is ceramic nanoparticles. Ceramic nanoparticles means they are the oxides, carbon. So ceramic nanoparticles, once again, they have the good controlling by their specific characteristics like size, porosity, as a delivery drug delivery agents, and in bacterial infections, and also for glaucoma therapy, and also in cancer therapy. Nowadays, these ceramic nanoparticles are also used in bone repairs. Coming to the next one, that is metal nanoparticle, as we have been listening from that time, that is gold nanoparticles and silver nanoparticles. In the same wise, even we have titanium, zinc, and copper nanoparticles also. Once again, these nanoparticles, metal nanoparticles, are utilized in several research fields, okay, including in bioimaging, and also in drug delivery systems, and also even in mechanical applications also. Semiconductor nanoparticles are very widely used in computers, cell phones, television remotes, and hello, hello.
Madam, your voice is not audible.
Now it is audible.
Hello.
Now
Now
it is
it's
audible.
audible,
Please
madam.
check your connection because 2-3
Okay,
times same problem occurred actually.
okay, fine.
Yeah, please. Thank you, ma'am.
Yes, sir. I have connected. Yes, sir. Yes, sir. Yes, sir. I've connected to Wi-Fi also. Oh, there is some problem, I guess. Okay. Coming to the next application, that is the mechanical engineering applications of nanomaterials. So we can see where all we can get use nanomaterials. What are the advantages of using nanomaterials in mechanical engineering? We can get lightweight composites and tribological coatings, and lightweight composites will enhance the strength. These nanoparticles, especially the carbon nanotube nanoparticles, are used in the structural elements, like even in aircrafts and other structures, which will improve the fuel efficiency. Okay, they also provide the improved stiffness. These three advantages are seen in lightweight high strength composites. Tribological coatings and surfaces. So tribological coating to get the high quality material properties. The alloying system itself is not enough to get the higher surface properties. So for that one, to improve the surface properties, we are providing the tribological coatings here. Coatings. A case study has been done here. In this study, nano composite coatings were coated on the surface substrate of MDN 321 steel, which is used in high temperature applications. This nano composite coating consists of a alloy powder, that is a nickel, chromium, aluminum, and yttrium, along with the nano P4C particles, that is boron carbide particles, along with the xenosphere in the coatings. Nickel, chromium, and aluminum yttrium possesses excellent corrosion and oxidation resistance. Okay, but because it is not hard particles deposit along with this cenosphere. What is this cenosphere? Cenosphere is a byproduct of a fly ash. What is fly ash? Fly ash is a waste product which comes from the coal thermal power plants. So the cenosphere is in shape and it is a pollutant also. If we use that pollutant, already the cenosphere and fly ash are widely used in civil engineering applications to prepare roads also. Some in some places even they have laid roads also using this fly ash. So if for in coatings also the cenosphere is used in little proportions. They comprise mainly of oxides of silicon, aluminium, and it is a mullite. They have excellent thermal conductivity and low efficient of thermal expansion. So they, because of these properties, it makes a promising material for a coating. So we have chosen the substrate material which is used in high temperature applications and also the coating material. So now how to coat this coating material on this substrate? To coat these hard materials, we generally prefer thermal spray coating methods. What are thermal spray coating methods? In thermal spray coating techniques, the material is heated and it is accelerated onto the substrate. Here we are using plasma spray process. We have different thermal spray processes like HVOF, that is high velocity oxygen fuel welding coating process, and detonation gun plasma spray process, and HVAF. There are so many thermal spray processes. Among those things, we have the researcher has chosen plasma spray process. Maybe the reason that in the plasma spray process, the standoff distance between the substrate and the jet will be very small, so that the escaping of the particles will not be there in this one. So to do that one, so these are the semi-majors of the feedstock powder. That is the combination of B4C, nickel, chromium, aluminum, and yttrium, and cenosphere. After that, after coating also, once scanning electron microscope image is taken to see that all the materials are coated. Few are partially melted particles are seen, and unmelted particles are seen, and even cenosphere is seen. When the XRD EDS of the material is taken, here it is observed that all the elements which are there in the feedstock powder are there in the coating. After that, the coating thickness is checked once. Okay, here once again, the coating feedstock powder, in feedstock powder we are using this nickel, chromium, aluminum, yttrium. The atomic particle size, average particle size of this alloy powder is 150 microns, and cenosphere is nearly 100 to 150 microns. These two are microparticles, whereas this is nanoparticle. Now, that is B4C. It only is the only nanoparticle that I am using here. After coating, the coating thickness is checked, and even the coating variation in coating is also checked. The coating thickness is observed to be 150 to 180 micrometers. Here, the B4C particle concentration is varied in different this one. When it is observed that even the bare sample, that is the plain specimen, plain substrate hardness is also checked. It is observed that with the 0 B4C particle concentration, here we are maintaining 80% alloy powder, along with that is the matrix, and 20% of reinforcement. In reinforcement, we are varying the B4C concentrations 0%, 5, 10, 15, and 20. Like this, the particle concentration is varied. And afterwards, it is observed that for maximum of 20% of B4C, obviously the micro hardness is more for this composition, and the porosity levels are also checked. If the porosity is within this range, the coating is said to be a good with very, I mean, porosity of this percentage is good in case of plasma spray processes. But the disadvantage of a plasma spray technique is the porosity itself, because in HBOF and all, porosity will be less, whereas in plasma spray coating, the porosity is much higher when compared to the other ones. But here the porosity is maintained by maintaining the parameters, coating parameters. Once again, the strength of the coating is checked using the scratch analysis. Even after the scratch analysis, the failure of coating is not seen. And it is observed that for 20% of B4C particles, the traction variation in the traction force is not much observed, whereas for the other compositions or by the other percentage of B4Cs, the variation of traction force is much observed. It may be because of the sinosphere. After the coating and the check of the after checking the strength of the coating and the thickness of the coating and checking the scanning electron microscopic images, taking the scanning electron microscope images, next is erosive wear of the nano composite coatings is done to check how much improvement is there. Here erosion wear tests were performed using central composite design technique. Okay, we are varying B4C concentration and impingement angle and temperature in 4 levels. Okay, so after designing the experiments, after drawing the interaction plots, it is observed that 15% of B4C plus 5% of sinosphere and 20% of B4C compositions showed similar erosive wear resistance. Maximum B4C composition exhibited maximum erosive wear resistance due to its hard carbides and oxides in the coatings. It is observed that 90% for 90% angle of impingement, okay, angle of impingement, the failure of material is seen in the brittle manner. At higher temperature, the material will fail in ductile nature. Even at this higher temperatures also, at 800 and 900 degrees temperatures also, the coating was strong. The failure of coating was not seen. It is seen that at higher temperatures, the material failure, the coating failure is seen like this, that is the smearing action. These coatings behaved like a ductile nature at higher temperatures. Okay, so from this graph, it is seen that for 90 degrees impingement angle, the maximum volume loss is seen when compared to the other impingement angles. From these studies, we can come to a conclusion that the Hello.
In which slide you are there, madam? In which slide you are there? I think your explanation with the
erosive studies of coated specimen at 600 degrees Celsius.
What I am seeing is tribological coatings and surfaces.
Oh,
select slide, ma'am. Select the slide.
Madam, I have crossed nearly 8 to 10 slides, madam.
We are following. Okay.
Are you following me, madam? Is it visible?
Yes.
No.
Yes, ma'am. Yes.
Okay. Okay. So these are the interactive plots. From these interactive plots, we can see the influence of temperature and influence of impingement angles and influence of composition. So at higher temperature, the failure of material is in the ductile nature. When it is observed that the 90 degrees impingement angle, like this, the study is done for different impingement angles. Here, I am showing only 90 degrees impingement angle, where this eroded region is divided into 3 zones, where the abrasive particles enters and they will leave. At these particles, where the abrasive particles enters, the failure is like a takes place in a smearing action, which is very less. In 90 degrees impingement angle, definitely the material will hit straightly. So the material will pluck off, as we can see here, and some platelets are seen here. and even the lip formation is seen here. Coming to the next studies, that is dry sliding wear studies. Here also the experiment was designed. Experiments were designed using central composite design model with 4 parameters at 5 levels. All coating compositions showed better wear resistance than MDN 321, that is substrate. The optimum before C concentration was found to be 15% before C, and load is 15 Newton. Pin temperature is 75 degrees Celsius and sliding speed of 500 meters is seen here. The particle concentration is the main influencing parameter amongst all 4 parameters. From these results, we can conclude that Cenosphere can be used in optimum.
Slide.
Hello. Hello.
Ma'am, yeah, which slide you are talking about, ma'am? Next one.
3D surface plots of interaction.
Select that slide, ma'am. We are seeing erosion studies. Still we are in erosion studies.
1 second, madam. I'll once again go and now, madam.
Now we are in slide 26, ma'am.
Surface 3D surface plots of interaction
Exactly,
of specific wear rate. Okay, so this is the procedure. I guess then I have to once again go back to this one and come back to the presentation mode. Okay. Okay, from these interactive graphs, it is seen that before C concentration, that is particle concentration, is the main influencing parameter amongst all 4 parameters. From these studies, it is observed that the nanoparticles which are used here will enhance or will improve the wear resistance, of the coating. The same studies were done using the microparticles, as micro hard particles as a reinforcement. Like micro chromium carbide was used, but the erosive resistance was improved, but not as much as in these studies. This is the we can see almost 150 to 200% of erosion wear resistance is increased. Even the dry sliding wear resistance is increased after using nanoparticles. Okay, so these are the applications of nanoparticles in biomedical and also in by mechanical engineering field. In mechanical engineering field, even we can prepare so many composite materials also using nano particles. But I have taken the case study of coatings, as that was my piece of work. Madam, is it visible the next slide, that is challenges and future outlook?
No, ma'am, still we are in a dry sliding wear study.
Okay, 1 second.
No, it's fine. Challenges and future outlook.
Challenges and future outlook. After understanding about the different advantages of nanoparticles, now let us look into the challenges of these nanoparticles. What is that? Is the first one is the scalability. That is the preparation of nanoparticles in laboratories is okay. That is, they are preparing in laboratories for studies. But whereas for wide uses, it has to produce in mass production in industries. That is one technique which is facing, that is the one big challenge that we are facing. And the another one is the cost of the nanomaterial synthesis and processing, which is very high, so which is limiting their accessibility. And another one is safety is also concerned. As we have seen, when the size of the particle is decreased, the surface energy will be increased very much. That is one advantage that we can make use as a advantage also, and it will act as a disadvantage also. That is the safety concern is also another one. These are all the challenges and the future outlook of these nanoparticles. So as engineers, we can look into these challenges, and if we can address these challenges to the limit, to very small limit also, we can make use of nanoparticles very widely, which are very useful, especially in biomedical industries. We can, if we can synthesize the nanoparticles in very less cost, we can save so many lives from the very dangerous diseases like cancer. So thank you for your patience hearing, and I really appreciate you all for your attention. Even in spite of these disturbances in my presentations, you have taken interest in my presentation. Thank you, one and all, and I'm happy to answer any of the queries.
Hello, ma'am.
Okay.
Hello, madam.
Hello. Yes. Ma'am, when you spray on nanoparticles at high temperature, 800, 700 degrees Celsius,
Okay.
then the nanoparticles will not be still nano size, right? Because when they when they are in high temperature, they become bigger. So, what?
Madam, at that temperature, they will be for a very fraction of moment, madam. Even a very small microseconds, it will be just, it will pass through that temperature and it will go and hit the substrate with high velocity. Okay, while coating. Okay, and in coating, they will be in very small amount, right? They will just enhance the properties, and as in my research, I have not seen any adverse effects at that high temperatures. Maybe because of that their high temperature stability also, these nanoparticles have given strength to the coating at that high temperature, or even working at high temperature also, the coating was not failed. The coating was, even it has shown the good adhesive strength after the erosive test also. These nanoparticles are used even in one application, like for cancer. This one also, they will be treating this cancerous parts by providing heat. That is, they are heated, these nanoparticles are heated, and that cancer cells will be heated, only that cancer cells. So even they are used as a heat transferring elements also. With my limited knowledge, I am answering, madam.
Yeah, that's fine. But at high temperature, I got it, ma'am. Ma'am, from mechanical application point of view, which is your which you think that these are the best particles for a mechanical point of view?
Madam, I'm sorry, I couldn't get your last point, madam. Can you please repeat?
Ma'am, we from mechanical applications.
Okay.
Nanoparticles, which is your favorite one?
Yeah.
Which is your favorite nanoparticles, ma'am, for mechanical?
Okay. In mechanical point of view, it is definitely, it will be carbon nanotubes and fullerenes, madam. And because if you want to work in these fields, some funding should be there, madam, because these nanoparticles are too costly to work on ourselves. Even the B4C particles which we have used are very costly. If I get some fund, I am very much interested to work in synthesis of nanoparticles.
Okay, madam. Thank you.
Thank you, madam.
Hello.
Hello, madam.
Hello, madam. I think no more questions. Okay.
Thank you.
Thank you, madam, for the information on nanotechnology in biomedicine. There was little network issue, but it's okay, madam. Anyway, you managed to deliver the session. Thank you so much.
Thank you for. Thank you, madam. Thank you so much.
Thank you, ma'am.
I can leave the meeting now. Hello, madam.
Yes, madam. Yes.
Okay. Thank you, madam.
Okay. I apologize with the participants for the network issue. Okay. Next session will start after 15 minutes. 7:30 we'll start. Thank you. I'll share all the PPTs of when the resource persons, as soon as they share it with me, will share it with everyone. I'll upload in the website. Thank you. Hello, everyone. We'll start with today's second session. I'll just give the brief introduction of our today's resource person for the second session. Dr. Srinivasa Rao Udara obtained his MTech from VTU Belagavi in 2005, PhD from Electrical Engineering Department in the field of nanotechnology at VTU in 2019. During 2015 to 2019, he worked as a co-principal investigator for DST research project. He is currently working as professor in the Department of Electronics, STJ Institute of Technology, Rani Bennur. His interested areas are VLSI EDA front and back-end tools. He has over 60 publications in international journals and conference proceedings and has granted 6 patents. His research interests are MEMS NEMS for biomedical applications, MEMS cantilever fabrication and characterization. And today's topic is characterization of analysis of nanomaterials for biomedical applications. We welcome you, sir.
Thank you, madam. Thank you. It's audible, madam?
It's audible and the slide is also visible, sir. You can proceed.
Thank you. Good evening to all. I am Dr. Srinivasa Rao Udara, working as a professor, Department of ECE, STJT, Rani Bennur. Would like to present on characterization and analysis of nanomaterials for biomedical applications. See, before going to start presentation, I would like to have a small introduction about my side. See, when I was doing my PhD in the year of 2015, I was not knowing about nanomaterials and nanotechnology. Even I don't have any knowledge about this field, but I had applied one proposal to DST, Department of Science and Technology, for medical applications, like medical application and as well as explosive detections. I got very good grant from Department of Science and Technology, around 40 lakhs. I had completed my PhD within 2 years, 7 months. I had submitted my thesis to the university. And later, again, few fundings I received from same department, DST, for the conduction of workshops, 3 workshops on MEMS and nanomaterials. So finally, I got very good interest on nanomaterials for biomedical applications. And last year also, I got one more FDP on MEMS nanomaterials for biomedical applications. So there is a huge funding on especially nanomaterials with biomedical applications from DST, Department of Science and Technology. Even tomorrow I have a small session. In that session, I will share you the list of funding agencies from Government of India. If you write the proposal, any proposal for societal applications, say nanomaterials in connection with biomedical applications, as per my knowledge, 100% you will get the funding from Government of India. So till now, I have received around more than 50 lakhs from Government of India for biomedical applications. With this, I would like to start the session. So today mainly I am focusing on characterization. So characterization is very, very important whenever if you are selecting any type of materials, say nanomaterials, and analysis also required because it is a biomedical application. So whenever if you are selecting the biomedical applications, you need to have knowledge in the field of materials and as well as medical also. Otherwise, the whatever the applications you cannot fulfill. So you must have knowledge in both fields, nanomaterials and as well as medical application. Then only you can find out a suitable material in the field of biomedical applications. So today my focus is on four ways. One is biological properties in nanomaterials. It is very important because today nanomaterials are playing very, very important role in the biomedical applications. Hence, you need to know about the biological properties from different materials. And second topic is nanomaterials and their biomedical applications. See, for this, I found a few materials which are the materials, common materials, is suitable for biomedical applications. Next, practical applications of nanomaterials in biomedicine by taking few examples, real-time examples, practical applications. Those applications, how it is suitable in biomedicine. So those things I would like to explain. And finally, the last topic I focused on analysis of materials for biomedical applications. So this is the information I would like to share all my professors and research scholars who are presented in these sessions. Thank you. Next, see, coming to the introduction part. See, as we know, nanomaterials playing very, very important role, a very, very important role, especially in biomedical application because it is a societal application. If you develop any materials which is useful for biomedical, it is very good for the people to save the life. And one important thing is, so everyone is working on, as per my knowledge, everyone is working on different types of materials with characterization. Only they are focusing on physical, chemical, and like other kind of properties. But in addition to that, coming to the biomedical, biological properties are very, very important at the nanoscale because based on the biological properties only we can have the application, and based on the biological properties only the application is going to fulfill. And where we will get these biological properties and what are the materials is necessary to identify the materials for the biomedical applications. So coming to the like biomedical application, the main important parameters are biological properties. So if you are looking into the materials having, there are a number of materials having many applications, but a few materials can found in medical applications. So for example, drug delivery and imaging, means medical imaging, and diagnostics and tissue engineering. So at current research work mainly focusing on two areas, research areas. One is medical imaging and as well as tissue engineering. Why medical imaging is important means today many of the patients are undergoing through MRI and CT scan. It is necessary to have very brightness image. So if the image is not brightness, it is very difficult to identify the problem of the patient. So and in brain, the damage, whatever the damage is very small. Hence, you need to get the very good brightness image for the identification of the disease or the where the problem is happened. That's why there is a huge research on medical imaging. So you can write the proposal to the DST to get the funding on this medical imaging. So it is one of the hottest area in medical imaging. And even tissue engineering also, biomaterials, nanomaterials playing very, very important role. Next, how to understand, see how these biological properties is suitable for biomedical applications at some particular applications we need to check. And especially if you are looking with the biological properties, Whatever the biological properties you found, so you need to have some important things. One is safe is very very important, because some of the nanomaterials are very risky, and those materials if used for biomedical applications, sometimes the patient he may die. So here you need to take care, you need to you need to study about what kind of material, how, in what way these materials are safe. So this is very very important. And safe and effective nanomaterials for various biomedical applications, especially diagnostics and therapeutics and drug delivery systems and tissue engineering. And scaffolds means this is related to tissue. So these are the major applications nowadays we are using by developing or by studying and by characterizing the different types of nanomaterials. Now coming to the nanomaterials, just now I am highlighting always what are the biological properties, why biological properties are required in the biomedical applications, and what are the biological properties we need to identify from the selected materials for to fulfill the applications. And one more thing here, as we know already, since from 4 days the sessions are going very smoothly, and I had attended all the sessions, and all the resource person taught very well on nanomaterials and as well as biomedical applications. And they have given very very good information on a nanoscale, and some resource persons explained about the basics of a nanoscale and all. I don't want to have more on the basics, and I am focusing on real-time applications for biomedical applications. So now coming to the biological properties, the first property is the size and surface area. This is very very important. See, for example, say if you selected one material, you have to see what is the size and the surface area. Of course, you know, nanomaterial is in the range of nanoscale, like 1 to 100 nanometers